Beautiful. So, first off, welcome to our second ZertoCon. Thank you all for coming here and sharing your time with us this week. You may notice two names on the board here. I could be Ori Mamluk. Trick question, I'm not from Israel, so I'm Sean Masters. Ori, I just want to share, if you haven't met Ori Mamluk, this is the guy who actually developed, continues to create features and functionality for, and acts as the senior developer on our virtual replication appliance technology. So he is here this week. He's not physically here this moment because he's also part of the opening act for the concert tonight. I won't tell you the instrument he plays, but I will give away that you will be seeing him later. So I'm Sean Masters by default. I first came to Zerto as a sales engineer about 5 years ago. Started managing a team, and now I handle all of the internal and externally facing system scaling between our support organization, our post-sales organization, and our pre-sales organization. None of this matters from an ego point of view, who cares who I am, but point being that I know an awful lot about the Zerto technology from all of those perspectives, right? From the deep support piece, the delivery perspective, and then lying about it a lot to sell it to you, right? So, so I get to spend some time with you today to talk about how we maintain consistency with Zerto. All right, because we're not using snapshots, we're not doing array-based replication, right? We're doing our own continuous data protection, and we're going to dive into how that actually works under the hood today. All right? So why do we need consistency? And for anyone who's sat through any of our presentations, webinars, you may recognize this slide. We might have prettied the graphics up a little. But we need consistency today because applications typically don't fit on a single server, or in our case, a single virtual machine. All right? And we need consistency because applications are growing more and more complex over time. So I come from an IT background, first in a data center space for a big real estate company here in New England. But eventually I wound up working for an e-commerce company, and that's where really this slide hits home for me. Because in an e-commerce or in a B2B or a B2B perspective, for any of you who support applications that actually go out to external consumers, be they businesses or the general public, this probably hits home for you as well, right? You don't have an application running on a single virtual machine. You have an application running across 7 virtual machines, maybe a dozen virtual machines, right? Maybe it's like the largest application that I've worked with since I've been here at Zerto. Nothing I've worked on hands-on myself, strictly from a data protection perspective in our space, but it was 106 VMs, right? And it was actually a single massive application stack. So very, very difficult to manage that from even just an operational perspective. But think of protecting the data and the disks that make up a 106 VM application. Think of it even in your 3 VM application. Right? And what that looks like, typically, is those virtual machines may live on different hypervisor hosts, and they're going to have different data protection settings, often different data protection solutions, right? Even for that first application. So you may have different backup technologies or a single backup technology running several different types of plans because your database administrator says this is the SLA I need for data protection and recovery. Your middleware tier administrator says these are the defenses that I need. the front-end app developers say, well, this is what we need, right? And of course, your actual data protection solution can't deliver really a uniform standard anyway, so you wind up with this kind of mixed SLA strategy for that one application, right? Now this expands out to multiple applications as well, and you can see it quickly gets very complex. Now you might be saying, before I go on from here, but I've got array-based replication, used it for a long time. I simply organize all my volumes into one monolithic LUN, or I spread them across a bunch of LUNs and I set up the same replication schedule, or maybe I use a technology that can create a bookmark across all those LUNs, right? And ship all that data across at the same time. So at least I get a uniform SLA for that application. What I'm going to talk to you about today is going to tell you and show you how that's still not enough to get true application consistency, right? But we'll get there. So to high level, again, you're all here at ZertoCon. I think you all know what we wind up delivering, right, is a uniform service level agreement across the virtual machines that make up that application. Okay, so you take all the virtual machines that make up your SAP environment, you put them in a virtual protection group, and until you look under the hood with me today, you trust your partner, you trust your Zerto SE, you trust your Zerto sales rep that, yes, what we're getting is consistent protection. Okay, and over the next 20, 30 minutes, we're going to see how we do that. So you can take our second application, put it in another group, take a third application, put it in another group with different SLAs. They can all have the same SLAs, that's fine. Ultimately, you get consistent recovery. So how do we get a consistency grouping? Well, before Zerto, we could group up virtual machines into folders or data protection plans on a system that does snapshots. We might be talking virtual machine snapshots. We could be talking storage-based replication, right? LUN snaps, store and replicate, right? We could be talking array-based integrated snapshots where you've got some agents on the VMs doing some special work. They all ultimately work in very similar fashions, right? So first, they freeze the data. They snap the data, they spin off that copy, right? But there's a bunch of challenges with those. Depending on the technology, and I've got to personally admit, but I think all of us know, these have changed over time. And what we've seen is a lot of new storage companies and data protection technologies come out that say, you know what, we know these are challenges, let's address these, okay? Let's reduce the stun or the performance impact on our application. Let's spend a lot of development time getting that as low as we can, all right? Let's maybe make management a little easier. Again, if we're talking about storage replication, we can place all the VMs on the same LUN. Maybe we can make it easier to manage that by stripping out a lot of the controls in the system, making the storage really simple to manage, okay? Maybe you don't even have to tell the VMs where to live anymore because you just carve out a gigantic data store, you map it into ESXi, and then you just say, you know what, we'll let a plugin just manage the placement there, okay? Before Zerto, you get this big I/O impact, right? So you're doubling write operations, okay? Over to target site, you're doing extra reads over in the production site, right? So between a lot of additional read-write operations, we're doing a big I/O impact. There can also be, depending on the technology, snapshot overhead. Again, it might not be something like a zero copy on write snapshot. It could be an application integrated, or we might call it an application aware snapshot, all right? Or it could be something doing virtual machine snapshots, right, where the overhead is much more visible because not only are there simply tasks running through vSphere, but you can actually see, in many cases, snapshots actually filling up through Snapshot Manager, and it becomes not just overhead on the environment, but an administrative overhead. Okay. And of course, other challenges like limited frequency, so you're talking higher recovery point objectives, less restore options, right? Because again, particularly when you're looking for business applications, you're trying to get the least amount of data loss, so it's not like you're going to go back to your really, really, really early copies here. But these are the challenges really before Zerto or without Zerto. And these are the challenges that a lot of other data protection companies and data protection startups have really focused all of their energy on, is let's use the same technology, but let's try to eliminate some of these pain points with some new innovative ideas, right? But from my perspective, nobody needs to do that anymore. Right? There's a reason that we got rid of the old rotary phones and moved over to a completely different technology. So how do we get consistency, and how do we do it without impact, and how do we do it in a unique way? That set of questions really is what Zerto was here and what we were built to answer. Right? So first, how do we get consistency without impact? We have to do what's called sync and keep up. In strict Zerto terms, we would say perform an initial sync and then achieve a state where we are meeting SLA. Right? So you see the status of your virtual protection groups and it says meeting SLA. That's the keep up piece. Right? So first we have to do that initial sync, and then we have to somehow perform continuous VM replication. And we call this the benefits. I really say these are the goals. Why would you build a solution in this fashion? Because we don't want to use snapshots. We don't want performance impact. We want it so that you simply select the VMs instead of having to manage either a separate orchestration system or manage your virtual environment or manage your storage. Okay. Much lower recovery point objectives, of course, because we're simply streaming data. Again, all the things that I think most of the folks in the room likely already know. Okay. What you may not know, though, is how we actually perform the initial sync, or how we then keep up to get into a meeting SLA state. So syncing and changing disk is our first challenge. And what if you needed to sync, let's say, a single disk, and let's make it a small one so we can simplify our challenge. And let's just pick a number, I don't know, 16 megabytes, right? So what if you just happen to have to sync a 16 megabyte disk? I got a couple Zerto SEs in the front laughing because they know the answer to this. It's really easy, right? You can read a 16 meg chunk, compress it, send it over the wire. It's pretty small, it's pretty fast, especially with today's data transfer rates. Now, at the same time, you can keep the IOs that are being written to the disk, right? Save those off to the side. Then you just have to write the IOs to the target disk. Right? I'm going to expand on that a little bit because I don't just want to say that without a beautiful graphic here that's going to show you exactly what I'm talking about. So what about a larger disk? Because I pick an arbitrary tiny little number because it's really easy, but you probably have an OS boot disk that's 40 or 80 gigs. You've got some data volumes that are dozens or hundreds of gigabytes. You've got database volumes that could be terabytes in size. So it's not a 16 megabyte problem. It's an 8 terabyte problem, right? That's pretty easy too. If we go back to those foundations, we can simply partition the disk out into a bunch of those 16 megabyte segments. We can then sync each segment just like we handled our one imaginary 16 megabyte disk. Right? And we can keep tracking new I/O, right? New writes that are going on that virtual machine or that set of virtual machines. And we can copy those off to the side. And then we can, if you see here on the screen, we can track both sets of I/O in some FIFO queues, some first in, first out queues. We can keep one queue for sync blocks, and again, our data off to the side for the new I/O. And it really becomes pretty simple. We just merge the FIFO queues together along the way. And what happens is we start writing the sync I/O off to the target site, and once that's applied down, right, you can think of our journal, the data's flowing through. So as we flow through to the right, the sync blocks write down, and then the new I/O writes down. So we've always got the new data over the old data. What does this mean? That as soon as the initial sync is finished, we will be in a meeting SLA state, right? It's sync and keep up. Okay. So you talk about a little bit about how the data actually flows in Zerto in order to facilitate this. And I'm actually going to correct myself and Ori on this slide, because it'll be a little bit deceiving. We actually pulled out an icon for storage here, which is technically not correct. All right, so let me walk you through what really happens here. So we get a protected VM write is issued from the virtual machine. And what that really means is that some change happened in an application. It wrote down to the operating system layer. That writes down to the virtual machine layer. The virtual machine says, OK, this is a committed write. Let's send it down to ESXi, and so on and so on and so on. Right? But we've got the Zerto virtual replication appliance on that host, so we can see all the I/O coming out of those protected VMs. So after the write commit, we can say, you know what, let's create a copy of that write and send it to the memory buffer on the VRA. And if you go back to a couple slides ago, we can take the data immediately when we see it, compress it, send it over. All right. And this brings us to our FIFO queue story with the first in, first out. We take that data, we put it into the journal. Right? As new writes continue to come into the system, they'll also flow through, and they simply write out the back end of the journal, right, to the replica volumes. So again, if we combine these concepts, right, where we are doing an initial sync and then a keep up, and then through seeing the data flow, this is what really allows us to perform that initial synchronization, but also track the ongoing changes in those protected VMs. Right? Remember, if we didn't do that, we would forever be behind. If we just did a sync, we wouldn't be keeping up. If we only kept up, we'd never have any base data to work off of. Okay. So how do you maintain consistency, though? Because I've only talked about how you get data from point A to point B. And really keeping the diagrams on the screen simple, I've only talked about it for one virtual machine, and maybe even just for one virtual machine with one disk. And if we back up several minutes, you also heard me say that applications aren't that simple anymore. So how can I reconcile these two ideas? Well, that's where not only replication of the data, right, but a couple of other key pieces of the Zerto solution come into play. So how do we maintain consistency when some event happens? When there's a WAN outage, all right? One of the sales guys here, I said I was an SE here at Zerto years ago. One of the sales guys that I used to work with had a great slide deck. Great not in the sense that it was the slide deck we were supposed to use, because he said, I don't want to use any of that. He just had a customer story. It was 3 slides. And the first slide, I won't bore you with the entire thing, but the first slide was a picture of this huge municipal truck that had just plowed through a demarc. Does everybody know what a demarc is? All right. So just guy hit some ice, swerved off the road, plowed right through a demarc. All right. So network outage all over the place. They happen. What if you have an enormous volume of data flowing through your systems all the time? Right? And how would you possibly keep that consistent? What if you, on the other hand, simply just have a problem of really low bandwidth? Okay, how is it that Zerto has customers with data flowing between data centers and offices in Alaska, and the same company might have offices over in Maryland? Right? How do we have a customer that might have a data center down in Texas who also has big oil rigs? Right? And how do we keep data consistency over that really low pipe? What if you're just upgrading Zerto? We've got to be taking some actions, pausing different parts of the system, maybe rebooting VRAs that impact our ability to continuously send over that data, right? So how do we maintain consistency in the face of any of these events? So there's actually two parts to that solution. And the first part is taking a sip of water. 1B is bitmaps. So we've talked about the initial sync and then keeping in sync. Another status that you've likely seen in Zerto, hopefully not too often, is the bitmap sync. So the bitmap is really a proprietary change block tracking mechanism, right? We're tracking the most recently changed blocks across an index. We store it in hypervisor RAM, right? That's actually a fixed size, right? So we're not going to sit there and balloon and take down your host. I will let the cat out of the bag here and let you know that that is a tweakable size. And we have had some customers who've needed to change that for various reasons. Right? But it's automatically leveraged as part of our two-part process for maintaining consistency. Right? So it's not something you have to manage. It's just a system that Zerto leverages in part of its ongoing operations. And then finally, even though we've got fixed size in hypervisor host memory, all right, it actually has a lot of dynamic granularity to it. So what we can do is we can track bits as they're changing through the system and tag those bits in the bitmap, all right? And say, yep, we have a pointer, a record of that change. So let's say, for ease of discussion, that we've got a WAN outage. So your two Zerto sites are disconnected. The virtual replication appliances are still operational, and the virtual machines in your environment are still operational. And your users or your customers are still working, so data is still changing on those virtual machines. So we can just keep tracking all of those writes. We can do that in the bitmap, right, by creating pointers to that data. But again, it's fixed size. So what we can do is say, as we're tracking along, right, maybe somewhere along the way, and we're tracking, and we go, we get a dirty bit here, right? Well, instead of just flying through, we can say, you know what? Let's actually blow that out, okay, and track every bit along the way to save space, right, by creating a layered bitmap. So the parent level bitmap here, even though it's a fixed size, we can just have an overall record that says, you know what, look at this other subset of data when you come back to me in the future and start syncing me over the wire, all right? So now, how do we recover from that WAN outage? How do we recover from having an issue of low bandwidth, or even something as simple as restarting several virtual replication appliances in the event of an upgrade? We can use the bitmap and sync the data across once that issue is resolved, because now we've got all the pointer data. We can simply go through that and identify all those writes that had changed across the way through the use of that bitmap and just flush all those writes to the target side. Right? So now we have them over at our recovery site, and we get back to a keep up state, get back to a meeting SLA state. But I mentioned there's two parts to the solution. Because if all we do is track the write I/O and then ship it across, well, we've got all the I/O in a journal disk and a replica disk, or a set of journal disks and a set of replica disks. Doesn't really help us go back in time at all. Doesn't really help us correlate the volumes at all either, right? So what do? We use checkpoints. So probably another familiar screen here, particularly, again, if you've seen a demonstration of Zerto or you use Zerto and you do failover testing, and hopefully you haven't had a real disaster, but if you have, you've potentially pulled this screen up. So you know that a checkpoint represents a consistent point in time in a virtual protection group, and you can go back seconds, minutes, hours, days, up to 30 days, right? It's usable for tests, for failovers, for offsite clones. Technically, checkpoints are even used as part of the move operation, right? For any of you who took the instructor-led training this week in the ZCPA, you know that in a move operation, even though we gracefully shut down the protected virtual machines and we replicate all the data over to the target site, even though all that data is over there and you think it's stable, it's written down, everything's good, we actually still create a checkpoint after that process. You're going to see why. Okay? And then we actually recover from that checkpoint as part of that move operation when we migrate those VMs over to the target site. So there's really two key points to remember about checkpoints. Is we need to think about completeness and we need to think about consistency. And a checkpoint is complete, right, in the sense that it's valid only if it exists for all the volumes in a virtual protection group. And then it's valid only if it's valid cross-consistent in sense of across all the volumes, the VMs in that whole VPG. So it's not just consistency if it exists across all the volumes, right? But it's not just complete if it exists across all the volumes, it's complete when it exists across all the VMs. And furthermore, it's actually complete only if it exists and is aware and available to both the protected site and the recovery site ZVM, the Zerto Virtual Manager. And then the consistency, again, has to be same I/O across the volumes in one VM in the VPG, and then across all VMs in that VPG and all their volumes. So how do we actually strive for that? How do we solve for the challenge of completeness and consistency in checkpoints? And just like we talked about the data flow for that imaginary 16 megabyte segment, right? We'll talk about the flow of the checkpoints through the system from the ZVM, the production VRAs, to the recovery site VRAs, and the recovery site ZVM. Okay. So the protected site Zerto Virtual Manager sends a checkpoint to all of the virtual replication appliances. Right. The virtual replication appliances then actually insert that checkpoint into the data paths of all of their protected volumes. And then the checkpoints are actually sent serial in the I/O stream. All right, so they're literally in the I/O stream that we were looking at earlier. Now the VRAs actually send the checkpoints across to their paired recovery VRAs. You may not know what I mean by paired recovery VRAs, and you may think, I thought I only paired the ZVMs, and that's true. As a user or an architect of a Zerto solution, you only functionally have to pair your Zerto virtual managers. The Zerto system takes care of all of the interconnections between the virtual replication appliances across your paired sites for you. All right. And we do it exactly because this is a very complex problem, and we don't want you to have to solve for it. We just take care of it for you. This is also exactly why you may have gone through an install with our services team or with a partner, or if you've deployed Zerto yourself, and we'll always say, yep, unblock these firewall ports bidirectionally, and yes, we really mean between all of your potential VRAs, right? Because we want to manage this set of connections for you. All right. I'll take it at the end if you don't mind. Thank you. All right, so now we've got checkpoints sent to the recovery VRAs. And then again, keep in mind, even though we talked about single volume, 16 megabyte segment, one VM, that we need to solve for our original challenge of a large application or a small application, but it's comprised of more than one virtual machine, like most of our applications today are, and they've all got a bunch of volumes, and we need to make sure that they are all being replicated, meeting an SLA together, but most importantly, recoverable to a consistent point in time where every VM, every volume in that VPG, the I/O is consistent. So now we get the checkpoint over to the recovery site. So now the recovery site VRA, we'll look at it from that perspective. So we receive a checkpoint, and we write that down to the journal, and that's an operation known as hardening. The recovery site VRA then sends an acknowledgement back to the production site VRA, say, yep, I have this checkpoint, here's the ID, I've hardened it down successfully. And then the production or protected site VRA can clear that checkpoint I/O from the bitmap. Remember, the bitmap is a fixed memory size, so we want to maintain efficiency. So when we flush data across, we want to check for data integrity through this process so that we can clean that bitmap out, so we make sure we have plenty of space in case we need that bitmap. So now, with the ZVM sending the checkpoint through the protected site into the recovery site, everyone agreeing that, yes, we've hardened this down, I acknowledge I've accepted and hardened this down, the production site gets the ACK back and says, yep, that's great, let's clear the bitmap out. The checkpoint's now persistent, and you can reboot the VRA or the ZVM and still have those checkpoints available when you go to recover back in time in the journal in a test failover, a live failover, or any of those other operations. Right? Declared potential if it's hardened only in all volumes. Again, this goes back to completeness and consistency. Right? So now we have a checkpoint that'll survive, but we've got to, again, make sure, is it hardened down everywhere across the board? Yes, okay. Then we can reference it as a recoverable checkpoint. But there's still one more problem to solve, and that is write order fidelity, or write order consistency, or data integrity, or whatever else we decide to call it this year. And I don't mean Zerto, but I mean our whole industry, right? We change these terms all the time. I like write order fidelity the best. I think it goes back the furthest throughout storage history, at least. So, we said a checkpoint's declared valid if it maintains write order fidelity across all of those writes. Remember, many VMs, many volumes, lots of stuff going on. But this is still a challenge that we need to solve for. We need to solve for this challenge of saying, you know what, how do we make this checkpoint valid? How do we maintain write order fidelity across all of the write operations that could be going on in all the VMs in this application? Well, let's think about what could break write order fidelity, right? Well, if the result of IOA is used in IOB, but the checkpoint only contains IOB. We'll show that to you on the screen exactly what we mean there, right? If IOA finishes before B starts, but the checkpoint somehow only contains B. What are we really solving for, I think will become more evident in the next topic I come to, right after this one, which, again, is solving for the grand problem of many volumes, many VMs. But for a single volume, write order fidelity is simple. Why? We have a single data stream. We can insert a checkpoint serially into the I/O path, send it across the target side, acknowledge it, comes back. We know we have data consistency. It's very, very easy. Right? Let's say we have VRA with one volume. We declare a checkpoint. Well, if that checkpoint being sent serially comes in and has writes A and B behind it, great. They both make it into that recovery checkpoint when you go to do a test failover or a live failover. If the checkpoint declaration by the ZVM instead happens after write A, but before write B, so what? We have write A, send the checkpoint across, acknowledge it, harden it. We can recover from it. We'll recover back to write A. Write B still happens. We'll catch it with the next checkpoint. If we create a checkpoint and I/O happens later, again, so what? We'll catch that I/O with the next checkpoint. So for a single volume, write order fidelity is very, very easy. But I want to go back to this part of the challenge. What if the checkpoint contains IOB but not IOA? And when is that a problem we need to solve for if I just said that for a single volume, write order fidelity is easy and checkpoints are always valid? The real problem is if we have two volumes, or two VMs, or two hosts, or 106 VMs, and 400 and I can't even make it up. It was 400 and something volumes across 20 some odd hosts. It was a big application. That is now an extremely interesting problem to solve for, because the part of the challenge that that situation introduces is the network and latency, or even storage controller latency, right? Or even latency introduced in the data protection solution itself, because maybe it can't handle firing off all those operations at the same time. And that's the problem that we solve for in Zerto. Because again, we can send that checkpoint serially in the I/O stream for every volume in the VRA. We just put it into the I/O stream and send it across. So we come way back from the gigantic application that I worked with and just say two volumes and two hosts and go back thinking about, okay, for a single volume, it's really easy. So if we think about that volume 1 on host 1, and we have IOA, and that goes on its merry way. IOB coming out of volume 2 on another host goes on its merry way. We declare a checkpoint. We insert it in the I/O stream, right? Well, when that data gets fully baked into the target site, and we get that checkpoint sent over by the recovery site VRAs, and we see it, and we harden it down, we say, oh, well, we have IO A and B. That's valid. Great. And then continue on the rest of that process that we talked about several minutes ago. The situation with a single volume where the checkpoint came between writes A and writes B, where I said, that's easy, we could throw B away, right? So now let's span that problem and solve for it across multiple volumes and multiple hosts and say, okay, so what if IOA was actually on one volume, on one host, and then IOB was on another volume on another host? Well, as long as we have IOA there, what do we say? We can't have B without A, but in this case, we just have A. This checkpoint we can declare valid. And again, at some point, B gets across, and then all the next series of I/O, another checkpoint declaration happens. We'll capture that IOB later. All right. Same thing from the last slide where we declare a checkpoint and I/O happens after the fact. Fine. That checkpoint first declaration is still valid. Here's our problem. And this is what we look to solve for in Zerto. Right? Here's the problem that you would potentially face because of latency. When we're sending the checkpoint and creating a checkpoint, right, Well, what happens when the data gets over to the target site, but due to some network latency issue or storage latency issue or some other latent issue in the target site, from the target site's perspective, IOA comes after the checkpoint declaration, but IOB comes before. How do we solve for it? We simply say that's an invalid combination of data. We're just going to throw it out. Try on our next checkpoint cycle. Right. So if we put all this together, right, we need a solution, and Zerto solves for a problem, right, of doing this without snapshots, right? Doing it by tracking every write that flows through the system, and doing it in such a way that we are not impacting application performance. Now, if we go way back to how we did things before Zerto, what we also don't want to do is even impact the source site at all, right? And that goes back to the data flow. IOs that go through the system, we just copy writes to the VRA and send them across, right? We don't do a write intercept, we don't stun anything, stop anything, and so on. Okay. More importantly, it lets us solve for the problem of recovering a large application. And I don't mean the data set size, but the number of systems involved in the application in a consistent fashion, right? Because now, again, we've reduced this problem down to its smallest part, which is a single segment of a single volume on a single virtual machine, and simply worked up from there. Allowing us to protect across LUNs, across storage arrays, but the part that we leave out here is across hosts, across clusters, across your entire virtual infrastructure, right? What I don't want to do is stand up here and sound like I'm pitching to anybody with this powerful yet simple BCDR line at the bottom, because I want to focus on this being my next most important part personally. So recovering that multi-VM application consistently. You know, if I go back to my time running IT at the e-commerce shop I worked for, that was a really big problem, right? We tried to solve it with a multi-layered approach of array-based replication, in-database replication. So I was an old SQL DBA. I didn't believe in clustering. I used to do T-SQL replication commands to keep my database in sync. Site Recovery Manager on top of this to manage the LUN replication piece. Backups on top of all that to manage the archival piece and as a backup strategy in case one of those other points failed throughout the system. Right? Recovering the application consistently was impossible. But again, the second part of that challenge was protecting across the storage environment, across the virtual environment, right? Across the network environment, as I just talked about latency. And solving for that by plugging in a solution, Zerto, that abstracts away from all of that management. Where now we're just taking the VMs, putting them in a virtual protection group, picking our SLA, and that's it, right? We click save, and off it goes. All right, so it's the unspoken challenge here, because what I strove to do today in this session is focus on the I/O flow and maintaining write order fidelity to allow you to recover that large application. But the part that this always leaves off is that human part of managing all that stuff. We can solve write order fidelity and data consistency with Zerto and give you this really easy solution. But the other part we're solving for that we very rarely talk about is the challenge of you, or it was me, sitting at the e-commerce firm, spending half of my day and having all these other tasks constantly rolling off my list, focusing on trying to manage across this whole storage environment, this whole virtual environment, and everything else. So I know we've already got a couple of questions. And for anyone who does have a question, I'd like to start with the two gentlemen who raised their hands first, and then happy to go from there. Pretty sure we have a good amount of time. What I'd also like to do is point out our CTO in the audience up front here, who's fortunately been smiling at me the whole time, so I know I did a decent job at least. But Oded Kadem is here as well in case anybody does actually stump the jump. I'm going to look to my lifeline over here. So I think you had a question, sir.
Yes, surrounding checkpoints and Bitmap Syncs and Delta Syncs. First question was, if the Bitmap Syncs are stored in the host memory and the Bitmap Sync's not complete, you reboot the host, does that switch over to Delta Syncs when it recovers?
Ooh. I might not be looking at my lifeline already. The bitmap, does the bitmap survive a VRA reboot? Yes. A host reboot? No. So if you've got a bitmap sync going on and trying to complete and the host undergoes a restart, it's still RAM, right? We can't save the host memory.
Okay, so that's not saved anyplace. Next question was, does checkpoint creation continue during Bitmap Syncs?
Oh, just pointing out all the bad stuff. No, it does not.
Okay.
So even though we're tracking all the I/O in the bitmap, what we're not doing is creating checkpoints and inserting them into the bitmap.
Okay.
Right. So what happens is the I/O will roll. We'll sift through the bitmap in the bitmap sync to identify use the bitmap to identify all the block data to ship across. We'll get it across first, and then we can start up sending checkpoints inside the data stream again.
Okay.
Absolutely. Were there three? Was there a third question? Okay. Yes, sir.
I don't know if I missed it, but are checkpoints user-created or?
Great question. And I'm going to repeat the question because I apologize I did not repeat the last one. So the question is, are the checkpoints user-created or question mark, right? How is a checkpoint created? So let me give you the best answer in IT ever. It depends. So one, they're always created by the system automatically, by a checkpoint engine, more or less, that just sits there and runs, call it every 5 seconds, trying to create a checkpoint, right? And if we go back to our scenarios, as long as we have a complete and consistent checkpoint at that checkpoint time cycle, then we've got the valid checkpoint to recover from, right? If that one fails, such as in our fourth scenario, we simply, remember what I said, we just can try again later. So we'll actually throw that away and not declare that a valid checkpoint and try again later. So in that scenario, you would have, instead of a 5-second RPO or recovery point objective, you'd have a 10-second RPO, provided, of course, the next checkpoint worked, right? Now, the second answer and why I say it depends is because you actually can create your own checkpoints in Zerto. You can do that in the user interface. You can do it through the API, all right? And I think we still have a PowerShell command laying around that lets you create a checkpoint as well. Think it's still there? Yeah. And then whenever you whenever you run a test failover, we will generate, we'll create a checkpoint for that. And actually in the recovery journal, if you were to go back into it, going back to the image I had on the screen earlier, they're just a bunch of timestamp checkpoints. But when you create a checkpoint, you can name it. And then when a test failover is kicked off, or when you execute a test failover, that checkpoint will actually say failover test at such and such time, AM, PM, instead of just a timestamp. Right?
So does the VRA read off the disk on the storage array, or does it read it from the ESX host itself before it gets to the disk? So my ultimate question is, if it does read from the disk, is there a performance latency that gets introduced on the storage array because there will be more reads on the storage array?
Okay. So the question is, when we do an initial sync, right? And how are we reading from the source, and would that produce any impact on the underlying storage? So we read through the VRA, which can see all the volumes on that host, and then since we're doing read operations, we are technically doing additional read operation on that host and against that storage. Now, I want to follow up to my own statement, because remember, we want to not create any performance impact. So how can we both say out of one side of my mouth that we have to read off the source site and off the source volumes, which means read operations, read activity, and we have to not impact storage performance? So we actually have I/O regulation built into Zerto, and there's a whole bunch more to that. But the very high level, what happens is as we're reading off the storage, if we see the latency go over a certain amount, we actually cut down the performance of the initial sync automatically. Right? And then if we see the latency bottom out again, we can improve the performance of that process. Right? So even though, yes, technically we will create additional read overhead on the storage, as soon as we see that pressure, we slow right down to reduce that impact. And this is only on that initial sync process. Right? I believe that, yes, sir.
So if you do a recovery, a DR from the latest, rather than choosing a checkpoint, is it consistent?
Yes, great question. So if you just do a live failover and you bring that screen up, or a test failover, and on that screen just says use the latest checkpoint, the question is that consistent? The answer is yes, and it's specifically because, remember, we're recovering to the latest checkpoint. And I think the issue there may be that I don't think we say checkpoint anymore. So instead of saying latest checkpoint, we just say latest. Right? It's a good question, though. Yes, sir.
Kind of two-part question. One, I assume you're using NTP on the host and just using the host clocks as your vehicle for detecting who's in there at any time. Is that correct?
So the question is basically how are we managing time in really across the Zerto solution in order to handle checkpointing at that layer, right? Doing it on a 5-second layer and seeing all the I/O. And the answer is we will leverage NTP, correct? And that's actually why in the install guide, in the admin guide, in the not published best practices guide yet, but it's planned to come out soon, is we actually tell you to make sure that you're using a valid NTP system, server, solution, et cetera, across your Zerto solution.
And then sort of a practical question. In a busy scenario, like your 20-host scenario, 400 volumes, 100 VMs, how often do you see this sort of slipping of the checkpoints? And are there practical ways to tweak the configuration or whatever to reduce slippage?
Yeah, so the question is in those larger application stacks, actually, if you don't mind, I'll pull the question up a little higher, because I think really what that question would say, if we know we do a checkpoint every 5 seconds and we know we could declare a checkpoint invalid if it doesn't meet our criteria, then really the I think ultimate question behind that is what happens to the RPO in the situation of a large application? And remember, the challenge is that those target resources, your target hosts, your target storage, they all rely on networking. We talked about NTP. Everything has to be in time. Everything has to get over the target site. Basically, as the application, or I should say, as the virtual protection group starts protecting more, it's not that it inherently loses RPO. It's that I think the follow-up to your question that you had started to say there was that it is inherently riskier than a smaller VPG, because now we've got more moving parts and more latency to deal with, right? So what I've seen practically happen is for those larger virtual protection groups, and I won't point or call anyone out because frankly I don't want to give away customer information, but there is someone in this room right now who's got a 22 or 26 VM virtual protection group, and their RPO, and this, this is a customer that I used to work with very hands-on all the time and work on a very large environment. But 22 or 26 VM VPG, all other things being equal, we were seeing about a 20-second RPO. Why? Well, because of the issue of network latency, and we're trying to go to a bunch of targets at once, so there's going to be a lot more opportunities for invalid checkpoints, right? So how to tweak for that? That's that's the ultimate question: is how to tweak for network latency across the entire virtual infrastructure all at once, and maintain that uniformly. That'd be a great challenge to solve with maybe the next startup. Was it? Bro, yeah, then we're really going to slow down the recovery point objective. Yes, sir. So the question is, how are we handling, right. Yeah, it's how do we handle, an Oracle database, a SQL database, redo logs, exchange, rollback, stuff like that. So, ultimately the answer is that we don't look into the guest OS or the application running on it, right? We just take all the I/O running on the VM and we see everything, we replicate it across. Now, in the case of something like a redo log or a backup directory in SQL or a transact log or something like that, we would probably just have you ignore that volume for replication if it was on its own volume, right? So Zerto actually has an option in the virtual protection group where you can go down into the individual volume and mark it as a swap disk. So we'll do the initial sync, but then we don't care about the keep up because you've told us that this is a useless data disk, right, in terms of tracking. And if you're talking on the other side, in the recovery side, can you give? So the offsite backup? Yes. Okay. Let me ask you to give, if you could give a scenario on that. Yeah. So the question would be if you want to reconstruct or maybe pull back a single or a set of files. Right. So now it gets more interesting, right? Because from a file level perspective, we could leverage journal file level restore if it's a Windows system. If it's not, and if we're trying to recover a whole file or a single transaction, right? That's when you would have to approach that problem basically to the side as some kind of workaround. Do something like a test failover to bring up that system somewhere else in a bubble to be able to yank the file out and pull it back, or use offsite backup. And if you're running that regularly and say, you know what, I can grab that file from over there, it's fine that it's 4 hours old or 8 hours old or whatever it is from my backup, and I can pull it back into the system. But the data stream itself, in terms of the ongoing sync and replication state, we won't dig into that to let you pull out that single file and restore it back to the system. Exactly. Yep. Absolutely. Yes, sir, and then yes, sir.
You said earlier that it's asynchronous replication is taking place?
Correct.
So if you were trying to create a manual bookmark and you were 8 seconds behind, is my manual bookmark at that moment, or is it when that 8-second mark hits the disk,
Uh-oh.
then you interjected the checkpoint?
Yeah. So the question is, if you create your own checkpoint, what's the time at, right? So the answer is when you kick off the create checkpoint, or when you click create checkpoint and then hit create, right? You'll actually see tasks broadcast out through like vCenter or VMM if you're using Hyper-V. And you'll actually see that stuff taking place where it's like create checkpoint, da, da. That's actually us going through that checkpointing process to make sure, hey, can we do this checkpoint right now as a valid checkpoint, right? And then the timestamp on it is at the time of execution. That's when we're injecting the checkpoint serially into all the I/O streams.
The 8-second I/O that I was waiting for, I have to try to time it for when that I/O says we are current.
Right, current or past, right? If you're going to create a manual checkpoint, you don't want to be sitting in the application and like, okay, ready, go. You just might have the app open and go, okay, did it happen? Great. All right, create a manual checkpoint. You got to make sure the I/O is over there, and then.
Because our app basically tells 15 servers to quiesce and freeze,
Okay.
and what that can take from what the latency says, depending on the amount of I/O changes. I don't know if I'm issuing a bookmark to work with
Ah.
early or too late.
So it's a great challenge. The challenge here is we have a multi-VM application that's got a quiesce operation going on, and you want to create a checkpoint while you're in a transactionally consistent state. Clear cache, write down, whole 9 yards. So I'll go back to one thing I mentioned earlier where Zerto has externalized commands for creating checkpoints or checkpoint requests through PowerShell or through an API call. So I would say in your script that does the VSS operation or the quiesce operation, if it's not VSS, across all those volumes, I would say you could actually place that in there and say, okay, I want to fire off a quiesce operation, and tell the VSS writer, hey, when you're done, or in the script you say, listen, when the VSS writer's done, great, fire off the next line. That's your Zerto checkpoint operation, right? And then and only then release back, when I get a listen back that said the checkpoint's done, release the quiescing. All right. Oh yeah, your quiesce is still, seconds, whatever.
Well, you can only do the checkpoint when you can do it. It's like saying do the next legit checkpoint you can do when you request one.
Correct.
It's not like do it instantly because you can't guarantee it be consistent instantly. You have to wait till one could be consistent across all of the VMs of the VPG.
Exactly. Now, what I would also, just to riff off that if I could for a minute, is go back to our I/O stream, go back to our multi-volumes and multi-VMs, and remember when we say consistency, it means we have all those I/Os in that checkpoint. So less than, I got to be honest, I haven't looked for months. So I could be wrong, but it's a really tiny number anyway. Less than 1% of our customers bother with VSS anymore on the Zerto protected applications because of this process. They know it's data consistent across all the volumes of VMs. You're not flushing memory. You are going to lose the data in memory. All right, that is the side challenge. Okay, but if we also go back to our other data protection challenge of not wanting to impact our application anymore, most of the customers that at least I've personally worked with, I won't be marketing and say, oh yeah, all of our no, the ones I've personally worked with their applications and protecting them with Zerto, it's a trade-off of saying, okay, you know what, instead of doing the quiesce-based data protection every hour, every 4 hours, every whatever it is, I'd much rather solve for the problem of data loss, i.e. reducing my RPO down to almost nothing, than I would where, hey, that 4 hour old data is amazing, but I'd rather have it be 10 seconds old and save the company $8 million.
I'm with you until I ordered a prescription for a patient. It got through the first half of my system, and now I'm not
Yep.
current, and now I ordered it again. Or did I give them meds twice?
Oh yeah.
I didn't get it at all. So, okay.
Yep. No, absolutely. And then that part of the problem is when I would look back to, let's stream it into your script and say, have Zerto be a part of that so we're aware of that you're doing that operation. I know there was another question over here. Shoot.
So it's around the RAM that's used, that Zerto uses on the ESXi host?
Yes.
What is that predetermined limit and that adjustable limit because you let the cat out of the bag?
Yeah.
And what is the impact when that goes off?
You know what? I can't remember the RAM count off the top of my head. If it's, is it, yeah, is it, yeah, it's a few, it's 48 or 96 megs, yeah. Yeah. So it's like 100, call it under 100 megs. Yeah. So if that fills up, then bitmap full, man, right? Not in production, but in terms of what we can sync across to the target site, right? But the other part to remember is the part of granularity in the bitmap. So we can say, you know what, this set of data is fine, this whole track of data is fine, so we can reduce that space down to the bitmap and worry about this other new data instead. We can't do it forever, though. Just checking the time here. All right, tell you what, supposed to wrap up now, but if anyone has any more questions, I'll stick around a bit, and I'll get off the stage and hang out and happy to follow up with you. Thank you.